The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So question number 11 wants us to once again find density. But they make it a little more complicated because now instead of just doing density equals mass divided by volume, we have to calculate the mass and the volume because it gives us 1.7 times 10 to the minus 27 kilograms and a radius of 1.0 times 10 to the minus 6 nanometers. But when we find the density, it wants us to solve it in grams per centimeter cubed. So the first thing we're going to do is convert kilograms to grams. So we're going to do 1.7 times 10 to the minus 27 kilograms. And we know that there's 1,000 grams for every kilogram. So we have 1.7 times 10 to the minus 24 grams. So, once we have this new mass, we can plug it into our density equation and say 1.7 times 10 to the minus 24 grams, and now we have to find the volume. Well, the volume of a sphere, it tells us, is 4/3 pi r cubed. But we need the radius to be in centimeters, and it gives us in nanometers. So I'm going to go and do a little bit longer of a route and say 1.0 times 10 to the minus 6 nanometers times, well, I'm going to bring it back to meters now. So for every 1 meter, there's 1.0 times 10 to the minus 9 nanometers. Let's do this a little bit differently. And let's just go ahead, I don't see the point in going from nanometers to meters to centimeters. That's just kind of a waste. So let's just go from nanometers to centimeters. We know that 1 nanometer equals 10 to the minus 9 meters, and 1 centimeter equals 10 to the minus 2 centimeters. So, we know that 1.10 or 1.0 times 10 to the minus 6 nanometers, if we did do the long way, I'll just show it real quick, would equal 1.0 times 10 to the minus 15 meters, because there's the difference of 10 to the minus 9. So 10 to the minus 9 plus 10 to the minus 6 equals 10 to the minus 15. So, if we go from 1.0 times 10 to the minus 5 meters times 10 to the minus 15 meters, and we wanted to get it to centimeters, 1.0 times 10 to the minus 13 centimeters. So, once we do that dimensional analysis, we say, okay, 1.0 times 10 to the minus 13 centimeters cubed times 4/3 pi. And that will give us our volume. So we have 1.0 to the negative 13 cubed times pi times 4 divided by 3, which gives us 4.188 times 10 to the minus 39 cubic centimeters. So, let's go ahead and take our volume, which is 4.188 times 10 to the minus 39 cubic centimeters, and plug it in our equation here. So we do 1.7 times 10 to the minus 24 divided by 4.188 times 10 to the minus 39, and it will give us 4.058. So density equals 4.058 times 10 to the 14th grams per cubic centimeter. And if we look at our answer choices, the closest one would be rounding 4.1 times 10 to the 14th grams per centimeter cubed. So, remember that if we look at L as in a basic unit, such as 1 liter, we know that a deca is going to be 10 to the 1, and we could just keep counting here. So the way I remember this is, Greg, my killer hamster, doesn't like dunking cookies, M&Ms, no peanuts. So, if we look at this and we want to get from nano to meters, it's just a -9 difference. But if we wanted to go from nano to centimeters, the difference here would be -7, and as we could see, from the 1.0 times 10 to the minus 6, if we just multiplied it by -7, then we would have got 1.0 times 10 to the minus 13 centimeters. So it's really good to memorize all of these dimensional charts so that it helps you out in your future classes whenever you have to worry about going from nanometers or centimeters to picometers. But the answer for this one, once again, is 4.1 times 10 to the 4th grams per cubic centimeter.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.